All right, we'll get started for this evening. Is the microphone loud enough? What's funny is people wouldn't say no if they couldn't hear me because the microphone wouldn't be loud enough. Or at least that's funny to me. All right, so my goal for tonight, I'm going to cover the Studio solution, which will help with some of the view model hookup that some folks had questions about. Then I'm going to cover exceptions, sort of orally talk about them, mention how you might use them, go over the actual docs that Chris links to in the prep work, to talk through some of those exceptions and why you would use specific ones of them at different times. Then I'm going to write a little tiny command line program to show sort of when you would use exception handling. I'll slide this over. I don't like how far I am away. Oh, no. That's better. It's only a little bent. So we'll cover the exception handling, small little command line program, and then finally, I'm going to go over the TechJobs 00 assignment, talk through some of the code that is there, and some of what is wanted. And I'll share with you the confusion I had when I read what you're supposed to do with the assignment, and maybe you will have had the same confusion. It will make you at least feel better, or it'll make you feel better because I'm dumber and I couldn't figure it out. Either way, it's a win-win. All right, so we will start with the user sign up. I'm going to show you it working so you have a better idea. I'm actually cheating and I already have it running in a different terminal window. So I'm just going to go to localhost, 5000 user add. And then you get to see that this very exciting add a new user form. And we'll just to show what it was supposed to do, maybe I should have done, that's why I had this open, to cover what the Studio mentioned doing, which was user sign up. We created a form previously where you would have users, they'd be able to go on the site, make a user that have username, email, and password. You can validate various parts of that information. The key for this one was to make sure that username and password and the verify password are all required. The email was optional. However, if it is provided, it must be a valid email address. And then a bit on the password needed to be at least 6 characters long. That's actually a terrible requirement. The password should be at least 8 to 12 characters long, favoring 12 characters in length. If you want, I can go into detail why, but that's less exciting. So ignore that requirement, make it 12. All of your passwords should be 12 characters or more. And then specifically, if the password and verify fields do not match, we get to show a special message in that scenario. So for each one of the various validation cases, We want to show a specific error message to help the user, because we don't want it to be incredibly frustrating, like it can be when you go to fill out information on a website or even on a desktop application. You fill something out and it just says errors at the top of the form. It doesn't really give you any context. You don't know what you filled out wrong. You start filling out your taxes and it just says something's wrong. There's only like 400 fields to fill out in your taxes, so if just one of them's wrong, it's great. In case you're wondering, H&R Block did have a bug in theirs that was equivalent to that about 4 years ago. I did not enjoy it. Make sure that you get the tight password when you render. That is very important, so that when I stand behind you and you're entering your passwords, you can just assume me or someone else is standing behind you anytime someone types a password, and they're just watching you, and they're gonna steal it. Gave a little context of how you would do that. And then specifically the implementation that was desired was to use view models. Covered on Monday. And they're pretty interesting. If you want to get a bigger, sort of broader idea around view models and how they're used in different paradigms, a common paradigm in the C# world is called model view space view model, often called MVVM. So if you're curious, MVVM, C#.net. We'll find lots of stuff. It will focus initially a lot on desktop development, but the pattern of having your models in your views and then something in the middle that's different than your controller, because we still have controllers, that makes it easier to manage the state of your views. So a view model helps manage that state. So it helps to say, oh, I'm going to validate with my view model, or I'm going to, in certain scenarios, I'm going to render a list, or I'll just render the first 3. Your view models usually hold that logic, and it's a good place for presentation logic to live. It's in that view model. It also, something we haven't covered, makes it much easier to test your code. When you use view models, it makes it a lot easier to verify, oh, if the user mistyped their password, I showed this error message. What happens a lot when people do not use view models, but they just use a bunch of if-else statements inside their template, it's really hard to test specific scenarios of, oh, your verified passwords don't match. So you try to write a test for it, so that later on, 6 months later, when you go and modify that code, you don't accidentally start showing the wrong error message or not showing one at all anymore. If you use the view models, you can test that your view model works correctly, and then if that test fails, you know you're not going to be showing it in the view. It won't catch all the problems you might have, but view models help tremendously with presentation logic and verifying that presentation logic is what you expect. So MVVM is the overall sort of pattern if you want to Google around for that. And specifically with our ASP.NET, there are a whole lot of cool helpers. They call them tag helpers. I think that's what they call them. That you throw on there and makes it a lot easier. I don't really care which one of these you use. So when you do try to go and use the view models and you go to say, hey, this will be my view model for this view. You can use either one that you want. Will come out to be the functionally equivalent. But to see something working before we go and dive into the code, so if I just try to go and create an account, so correctly says username field is required, says the password is required, and says the verify password field is correct, is required. we'll see the correct message. Now that's not a valid email. Now you'll notice that error message was different. Right there, I just typed in, and it didn't submit to the server. The reason you know it didn't submit to the server is you didn't see any loading indicator at the top. If you're really curious, you can know it didn't submit to the server because you open this network tab, click create account. No network traffic, but you did get this little built-in, please include an email address. What's occurring here is something that came out in the last few years with HTML5. You get automatic form validation if you declare inputs to be of certain types. So this is referred to as HTML validation. So if you wanted to look around for different ways that you can do it, it's called HTML validation. The nice part of it is that it's built in and you get nice little hoverovers that tell you that. The downside is when you do then go and implement here, but there are ways to take advantage of what the browser is giving you, and it's automatic validation and making all the messaging show up how you want it to. And if you're really curious, the underlying technology is called the constraint API. So if you want to look into that HTML constraint API, that's where you would go and find out all the different ways that you can set up different rules for validating data that's being entered before it ever gets to your server. With the caveat being, that's all only, so it's nicer for the user. Always validate data that comes into your server. Assume any data submitted to your server is an attempt to damage your software. Treat all data as malicious. You'll have a much safer website. So I'll go and so we submitted, it failed again, but it kept the email address in there that was correct. So let's say we're going to go and add a new username, which if you do go to a website, try not to take that username. I've been successful in never having to get a different one. All right. So now we have the username and the email working. The error message went away. Notice I typed these passwords, but they didn't match, and this one went away. Generally, if someone is submitting a password to your website, and for whatever reason it doesn't validate, you should not send it back to them. The less time that you spend sending secure data like that over the internet, the better. And they didn't match because I purposely typed them wrong. And then now we have a new user. And then we can go back. And there's no list page. But the way that all of that works. So as you would expect, we have controllers, models, views, view models. Same as what, other than the view models, that's how the user sign up has existed with models, views, and controllers. As I mentioned earlier, view models are another layer or abstraction that are different than controllers. Controllers, strictly in a very general sense, let you take data from some models and put it out in some view, some form or fashion. What view models give us is a nicer way to say, all right, controller, you'll interact with the view model, and then the view model will know how to interact with the underlying data model. So the controller uses the view model to communicate between the view and the model. So then all your controller really is doing is handling routing of data, send it to the view model, and then take it from the view model and send it to the view. It's not really doing anything with the data anymore, which makes it a lot easier to test. And as you start to write more, it makes it a lot easier to reason about what's occurring in the application. So we only have 3 routes for our user controller, or 3 action methods. We have the index, which shows that useless page that you saw. We have the add. And then we have the add with a post. And it uses that add user view model, which I haven't shown yet. But it's using, really all that matters here is that it is using an object that has certain expected attributes. And then if it messes up, passes in that view model, renders it back. If it is valid, so that model state is something you sort of get for free. As part of using your view models. So if you read what it sort of says here, it contains the state of the model and model binding validation. You get that because we're doing that binding here. So when we had mentioned before that doing that attribute binding in the controller, where you go and bind your model there, by doing that, we go and get these other attributes of our controller defined for us, and we get to use nice things like it's valid. Returns whether or not it's valid. How do we know it's valid? Well, that is what we went to define in the view model. So if the add user view model, so we'll open this up. As you probably expected, it has a username and email. Username is using the required filter. And this uses the data annotations, so data type comes from there as well. And that required attribute is what goes and tells, so when you go and use the helpers and the views. So to make it a little more clear, we have the add. So here we have username. And what happens, because we're using this tag helper, the ASP for, and then the ASP validation for, we have that username. That in conjunction with how we define our model to have this required filter for username is what goes and makes it render a form where that value is required. So if we come in and inspect our HTML, you just come in here, zoom in more. So sort of as the prep work had mentioned before, it automatically fills out a bunch of that for you. And then the only piece that we've actually gone and filled out is just username. And then our add, we just sort of define the markup to make it easier to fill it out. So by using the view model, you sort of get a whole bunch of markup for free. You don't really have to worry about it.
Is that input class form control? Is that a Bootstrap class?
So the question was, is the class form control a Bootstrap class? Yes. In Twitter Bootstrap, in order for all of your form inputs to be styled similarly, if it is a text input or a string input of any kind, you'll want to use that form control. So all of these are, as you can see, sort of free text entries. Those all use the form control. That's why they all end up being a little rounded with the gray, and then when you click, they get that drop shadow. That all comes from this form control class. So you can see over here in the CSS attributes, it also makes them display block, which is why they show up one after another. The advantage of using Twitter Bootstrap gives you decent looking forms with little of your own effort being having to give. The other piece here to look at is that here on email, we've gone and used, so we're still in that data annotations, and then we're saying this is an email address. So what ends up happening is it goes and creates a form control whose type is email. Chrome is a browser that recognizes email, and there's actually a whole bunch of benefits you get for having the correct type given on an input field. One of the big advantages you saw was automatic validation here, where I typed it in, it was like, oh, it's not an email. You might have thought that I didn't put a dot something afterwards wasn't valid, but the actual requirements for an email address are dumb. You can put a lot in an email address. One of the things that's nice though, a lot of browsers understand that and will validate it for you. You can add your own further validation if you want what you would consider to be a more realistic email address. One of the huge advantages you get by putting type, having the correct type, be it number or email or something more specific like zip code. On mobile devices, when people go to use those fields, that's why the keyboard changes when you're on different websites and you click on input fields. That's why on some websites, you're like, oh, it was really easy to enter my email address. And then on other ones, it's very difficult. It's because they're not properly defining the types of their inputs. Now, something that's awesome about these view models, and this isn't something you get, so I've used a fair amount of other web frameworks. As much as past me would be happy to say it, the C#.NET framework is pretty awesome for being able to easily spit out a lot of these forms and be able to use them. So as you're all well aware, I've written a lot of Python. All of the frameworks I've used in Python do not have something as deep coupled and simple as this is. There's usually a very tight amount of coupling between your data models and the way they validate in most frameworks. It's something that's been pretty, and that tight coupling, what I mean by that is you should. So we have our add view model there, and then we have a user model that's completely separate. Our user model is super simple. It's just username, email, and password. In a lot of other frameworks, all that validation logic we have would have to be included inside of this user class. even though that's not really where it belongs, because all you care about for your data is that they have a username, email, and password. You don't care about all those other pieces when you're just looking at the data. So that's one of the things I like about this view model. It separates it out and gives you loose coupling. And the inverse of that, it also gives you tight cohesion. So if you're wanting to Google search those types of terms to figure out ways of writing applications, loose coupling, tight cohesion, those are the awesome $2 words for the night that you can Google search in relationship to how these are not tied together so tightly. So it's one of the things that's nice. You tell it, oh, this is an email address, you automatically get that email address validation, which will be relevant for the OO assignment. I'll talk more on that as we move towards it. So next we have the password. And this is where I actually think the built-in validation things that this have get to be really cool. I was pretty excited when I saw it. Maybe you weren't as excited as I was, but I was pretty excited. So we know both of them are required. So we put required on there. And they're both data type password. That is very important because we want our HTML that comes out to say type password. That's important for multiple reasons. Number one, people can't see what they're typing in. Number two, if you use something like LastPass or some password manager or Google Chrome password manager, I can go here, and then I could go and actually more easily fill out passwords. It'll sort of auto-fill out once the user's already been there one time because it knows where the password field is at. And then for the last field, it's also a type password, and it has to match the other password. Now, it might seem like there's a bunch of annoying extra nonsense inside of your HTML there. When you start to incorporate JavaScript into your application and your framework is always outputting extra things automatically for you, it makes it a lot easier to hook in and have a much more rich user experience. So it might seem like too much up front, that's sort of jamming a bunch of stuff in there. More actually makes it a lot easier when you start to use JavaScript and add other rich pieces to the application. So the way that the password automatically gets set is saying required and it's a type password. So that meets the other two requirements. And then finally, the verify password is the same too. It's required and its data type is password. And we override it in the same way that the cheese name was overridden in the prep work. This verify password, we override the display name. And that's why it says verify password and not just verify. And then here, this compare is what is pretty cool. And you tell it to compare itself to the password data that comes in. That compare, we can look at it, the property compare with the current property. So this property, which is the verify, you tell the other property it should compare itself to. Under the covers, this is doing something that's called reflection in order to go and find it, because you notice password is a string here. But this is where it's easy to catch once you start writing tests, because this is a view model. Once you start writing them, it's easy to catch if you mistype password there, because you'll go and write a test, that has a capital P for password, like it should, or even a lowercase one. Either way, your test will break if you're not referring to the correct variable. The other cool part here is this error message, passwords do not match. You just get to define it there. And this is where that display really starts to come together. You're defining your error message and explicitly having what is view data shown. So that's where your view model starts to take over the logic of your presentation layer. Another what is this called? That's right. Another term often used for view models are presentation models. They roughly do the same thing. Just in case you're Googling around, you're seeing a bunch of different terms, you're like, oh, they talked about a presentation model, I haven't heard of that. They're very similar to view models because they help manage the presentation, just like the view models are doing. The view model, in my opinion, is a bit more explicit around what you're doing. It's glue between your view and your model. Presentation model is sort of arbitrary. The only reason I bring up presentation model is so you're aware if you're looking at solutions or trying to figure something out while you're looking around, that is another term that may be used. And this is really it for adding that validation. So we have a lot that's built into the .NET framework that we can use to get a lot of validation for free. And just to make because I didn't go over so our user model, super simple, it didn't change. So just got me username, email, and password. Our controller just checks that it's valid. Because we're using a view model, it's located where it is in the folder structure, and we are using these data annotations. Defining your view model, using these data annotations, and then having your model binding occurring here is what allows this model state that is valid to work. Sort of just kind of magically go in there and you can ensure your view model is valid. So the two things that are needed to be able to do model state that is valid is you have to do some form of model binding. So in this case, we're binding our view model that gets submitted. When we go look at that class, and our view model is just a public class. Because it has attributes on it that are filtered with the data annotation, the framework automatically knows, oh, okay, I have this binding. I can now validate that each one of these attributes that came in my post request is correct. So those three things together is how it's able to know and validate that the data submitted is as expected. Jonathan posted 2 questions somewhere and I have lost it. I found it again. I found them. I wanted to make sure I was covering the questions people had before I moved on. So then finally, the way that this actually goes and gets pulled in here is you have to use that at model, which then defines the view model you're going to be using. Really, it's the model you're going to be using, but we're using view models. And then you tell it the type that is going to be used. In our case, we're giving the fully qualified type name. Having that in there is why when it renders, we're able to use these tag helpers, ASP4, ASP validation for, and it automatically generates the markup for you. Without defining that model, it's not going to know how to pull it in and know what the type is and know how to properly read the username property on your view model. So the key for getting rendering to work correctly, you'd find your class, you use these data annotations on your properties, and then you use these tag helpers. And if you notice, you're not actually filling out username anywhere in your label, but it is showing up here. And that's because you've defined it to be used as your model, and it automatically goes and uses the property value as the name. Well, the property name is the name for your view. You can override that much like you could, so that display name. Oh, no. Here. We're to display name, verify password, you can override it. Otherwise, it does more of what is referred to as reflection and looks in, sees the names, shows it. As you get further along, you'll likely often override display name because you'll want to do what's called localization and internationalization, which is allow users that speak different languages to have those labels be in different languages. But we won't cover that at all. Just keep that in mind, that strings, where you're just writing them out here, it's not exactly how you would do it once you built an application that you had multiple people speaking different languages using. It'd be a little bit different, not that much different, but a little bit different, especially when it comes to the raw strings. So the email, password, and verify are all the exact same setup. And if you notice, this is something that's actually really nice about the way that this all works, is we know all the fields we want. So if you wanted to, you could write this code differently so that you're not having to write username, email, password, and verify out. And you could write your own helper that would generate all of this based on your view model. And those kinds of helpers do exist. So when you know that your markup is going to be identical and the only thing you're changing is this value in all three of them, then you won't need to type it out every time. But for now, we're going to keep writing out the markup so that it's more clear what's occurring. And that is the solution for the Studio validation. Are there any questions around how that view model works? How it goes in there and handles validation? As you start to use it more, it will make more sense. And as you get into more complex scenarios, you have to use more of the more complicated filter helpers, like this compare. It'll start to make more sense how you can override and you can make the values be what you're wanting. If there are no questions there, we're going to go hop into command line program. before we do that, so next up, we will cover exceptions. I've mentioned it a few times, how exception handling is something that you will do. It's very common. You feel free to read this page. Like all the Microsoft pages, it's a good bedtime read right before you go to sleep or as you're going to sleep. Most importantly are the sort of built-in exceptions that you have. Exceptions, as the reading mentioned, are how you can control or handle errors that occur in your application that you do not expect. And that is the key to exceptions. If you expect an error to occur, you should not be managing it with exceptions. If you want to Google the general terms around that, it would be control flow with exceptions. You shouldn't do that. You should never have code that says logic off based on the exception you're getting, because you should be validating the data before you allow a bunch of exceptions to come in. Of course, there are exceptions to that rule, especially if you work in legacy applications. So say, for instance, you're responsible for just taking a bunch of data from a huge amount of random sources. Like say you're an advertising firm and a bunch of different companies just send you information about what they want you to go advertise. It might be likely the data they're giving you has problems in it you don't expect, but rather than just crash your application, you should catch some of those exceptions and tell them what's wrong. But you could also validate it up front.
There's also the case if you're writing a library that doesn't necessarily want to catch exception. You're throwing your own exception.
Yes, so Tom brings up a good point. This is one of the reasons these built-in exceptions exist. If you're writing your own library, so if you think about Python, we use that Jinja templating library, and it sort of raised its own exceptions. So in a library, which is code from another person, company, place that you're going to pull in and use in your project, a common practice is for them to create their own exception. So they'll create their own exception class that inherits from one of these to then be very explicit about what you have done wrong. So for instance, in Python, there is a library that a lot of data scientists, statisticians use called pandas, NumPy and SciPy. They have a whole lot of very specific exceptions around if you try to do incorrect. You're probably not very excited about a matrix algebra in the library. If you try to basically do operations between what appear to you to be correct, what one of the attempts to say multiply two things together, it will throw exceptions that it has custom defined so that you know, oh, I multiplied two matrices that can't go together. Or, for instance, if you were to write some biological program where people could theoretically combine different chromosomes from different animals, if you attempted to combine two animals together that did not have equal chromosomes, then that would throw a custom exception to say, oh, these animals are not compatible. If you were just mixing together various species to go and create a new one. Now these built-in exceptions, so there's the base type exception, and then from the base exception, all other exceptions inherit, either directly or indirectly. And that's why anywhere in your code you can do try and then catch exception, and if an exception happens, you will catch it. You should almost never write catch exception generically, because what that means is you're going to be swallowing whatever error actually happened. And as you build applications and you start to get a lot of users and they do a bunch of things you do not expect, if you're catching too high of an exception, you'll never really figure out where your code is broken. So you should rarely just catch all exceptions. And they even say it here. Example, none. Use a derived class. And the same for system exception. Use a derived class. So then we have a whole bunch of very specific exceptions. One of them is this index out of range exception, which you have probably ran into. Happens in lists and arrays whenever you attempt to go one past what is available or one before. And we'll raise this index out of range exception. Null reference exception happens when you attempt to use an uninitialized variable. So this is why in all of my code, when I have lists of students or lists of courses, in my constructors, I always created an empty list. Because if someone attempts to access, say, student.courses or course.students, and you haven't initialized it, you will get a null reference exception raised at runtime. And you want to avoid all runtime exceptions that you can sort of predict. I'm not going to go through all of these exceptions. The invalid operation exception is a very common exception as well. That will be a very common one for third-party libraries to subclass and make their own. Because odds are when you attempted to use something in their library, you tried to say combine types that couldn't be combined. So you get that invalid operation exception when you attempt to add two types together that don't have a definition for adding them together. If you see a COM exception, that means you're writing Windows code directly. You probably won't do a lot of that. So, on to more of onto more of an actual example. So we can come here. Yay. And not now. So we're going to write a little program here that will take user input and add that user input together. So initially, we're just going to take we're just going to get two numbers from our users in our program. We'll read it. We'll read what they give us. We'll do the same thing. For our second number. initially, what we will do is we'll do this in the naive way. We'll come here and we'll just say the sum is equal to I'm not using the one. There we go. Found something I didn't know the difference of. Read line is for strings. So we have our sum of numbers now, and then we can do a console.write. Break it up. And we'll do that. Console.read so that it stops. So right now we've done no exception handling. Okay. So we'll put our first number in, our second number in, and I decided that having I decided showing the result was worthless, so I'll put the result in there. There we go. So then we can see the result. We can run that again. We'll add 5 and 0 together. Aww. So now what we get is a system.format exception. It's actually pretty helpful. Input string was not in a correct format. Then it gives you a bunch of other things here, the string to number. What you may not have seen is I actually just typed the letter, capital letter O instead of 0. But that's something you'll actually see quite regularly when users copy and paste data, and what you're asking them to is they're not going to be able to tell if that's a 0 or an O. But one way to handle this initially is we can come in here and we can say number 1 is our second number. So it still hasn't fixed it, but now we've separated getting our numbers out. Now if we read the documentation here for parse, it mentions that it will attempt to convert a string. Specifically, it says it will return to 32-bit signed integer equivalent to the number contained in S. S, a string containing a number to convert. And then it tells you what is actually important information to have. It tells you all of the exceptions it will throw. So if you write a third-party library, this is what Tom had mentioned earlier, you're going to throw exceptions, and you expect to throw those exceptions if somebody does an incorrect operation with your library, your function, your method. You should call out which exceptions you're going to throw. So in this case, argument null exception. So if you attempted to pass an uninitialized string in there, it immediately throws an exception. Because it's stating, no, you're not allowed to attempt to turn null into an integer. That's not allowed. Next one is format exception, and this is the one that we got. And it specifically says, is not in the correct format. And then finally, overflow exception. You won't care as much, but if your integer is larger than what can be expressed in up to 2 to the 32nd power, if your number falls outside of that range, it's going to throw an exception. But probably not going to happen right now. So when we know we want to do something, we could always what would be more common here is you then say number one, then you go and define it. We'll give it value. So now, for the first number, that was an example of what you should not do. If you notice, I just caught the general exception. We broke on the second one. I got ahead of myself. So line 27. That's actually because I did those out of order. We'll get rid of that. Now they're both handling it. The other one, that initially broke because I defined them out of order. I did 2 before 1. So now we get 0, but that's not what we want. This is not useful for a user when you just go and generically capture an exception. So in this case, parse explicitly states that the format exception will be given. So the exception we probably care about for us, format exception. We'll catch that format exception. If that happens, for right now, we'll default it to 0. So now if we come over here, we'll run it, and we get 0, like we expected. However, if we go and enter an integer, we can still get that Stack Overflow exception, which we would want. So in our case, we don't necessarily want to handle that directly here. So what we're doing is we're just wanting to add two things together. So say we wrote a library here where people could just arbitrarily add any two integers together. We would want them to know that, oh, their integer was too large. What you would most likely do, I'll cover more on Monday. We can talk about it. Is when you see this format exception, you would likely put that in a while loop so that you could try it, and if it doesn't come out, it would fail. In this particular example, parse specifically has another method you can use that handles the exception for you. But I wanted to give at least a brief example of exception handling. But I can cover more in depth on Monday. So if you're having questions on how to do exception handling, feel free to post those and I will do my best to answer them. I will also walk around tonight if you have questions around it. All right, now you get to stand up and switch. For the last time, in this space, well, likely for the last time.
Oh yeah, we'll have different rooms.
Yeah. So you don't have to stand up and move around. This is your last time. You're gonna mourn it. You're probably gonna be upset, but that's all right.
At this point, everyone